Research review. So I've read this already, but it's good. It's a nice treat that I was not anticipating at the time that I originally reviewed this. But yes, we'll get into it and then I'll explain why I'm so excited. Zero click RCE in Figma Desktop, a race condition prototype pollution chain that escapes the plugin sandbox. There we go. So this is by davensec. So he threw this important note at the beginning. Let's read it. Before getting into the details, I want to note up front that Figma responded and fixed the issue within a few hours. At no point were customer environments exposed. With that context, here's a write-up of what was found and how it was handled. TLDR, benign looking counter function inside Figma's variant handling code, e.g., I think that's like the minified name on whatever build, that's funny, was vulnerable to prototype pollution. On its own, it just crashed the app, but by letting the plugin context survive the crash in the main context, winning a race against internal do not use rerun plugin, and flipping the JSX debug feature flag, I unlocked a second, far more powerful prototype pollution inside the Figma JSX deserialize expression evaluator. From there, a polluted error handler gadget turned pollution into XSS, and a forgotten write to file path IPC on the Electron desktop app turned XSS into cross-platform zero-click RCE, all triggered by a victim running a published Figma plugin. This is the long version of how that chain together, and more importantly, how I thought about it. So I like this write-up because it's a cool chain. There's, in my opinion, extraneous behavior here that's unnecessary, but I'll get into that when we get there. It does not take away from the chain in any capacity, and each like major step of the chain is, man, it's so yes, I like this kind of bug. I love these like full chain electron bugs where and then just like taking, all right, we're gonna get into this. Here we go. So zero, why I kept looking after it's not exploitable. I'd already dug into Figma's client-side architecture for previous reports. Every time I looked, I came away with the same conclusion. The sandbox is solid, the public plugin API is hardened, and nothing interesting leaks across the trust boundary. My previous reports literally said sandbox escape was not possible, but one question kept bugging me. What if I could just access one of the APIs that Figma only gives its own developers? Not break the sandbox directly, not find a parser bug in a public API, just change which APIs the plugin is allowed to see. That framing is what eventually cracked the whole thing open, so before we dive into code, it's worth internalizing it. When a sandbox is too well designed to break head-on, go after the configuration that decides what's in the sandbox in the first place. I've had a great bug where it was a matter of, it's like I was able to perform some behavior that led to a dangerous function being passed to the sandbox and get code execution that way. But this is so much more complex than that because it's actually, and looking at it this way, it kind of makes sense how it happened. But I'm kind of getting ahead of myself here because just like turning the first gadget in this into something actually usable rules so much. One, a quick primer on how Figma plugins actually run. If you've never hunted on Figma, one paragraph mental model will make the rest of the write-up much easier to follow. Yeah, so I feel bad because like my original pass through this one, I did have to figure out this, and now I'm kind of speaking like it's implied. So I'll try to break down this in terms that make sense. Figma is a web app and an Electron desktop wrapper around that web app. When you run a plugin, it doesn't execute in the same JavaScript realm as the Figma editor UI. Instead, Figma spins up a JS VM, an internal JavaScript VM, and the plugin code runs inside that. So JS VM is weird. I think it might be WASM based. So like this still runs in like a web browser context. It's not in like the backing node process, and this is web. But I think it's like some like WASM based quick.js environment maybe. I don't know. It might have changed. I forgot to figure it out properly. And it sounds, serialization between the JS VM environment and the outer layer sounds like very interesting spot to explore for funny behavior because like how do they implement that? Anyway, that's like library level bugs though probably. The plugin talks to the main Figma app through a carefully curated bridge, figma.create component, figma.current page, figma.combine as variants, and so on. Each of those Figma methods are explicitly registered on the VM side and are backed by a callback that runs in the main trusted context. Yeah, but how does the serialization of the data that gets sent between these environments work? That's like immediately, well, serialization and deserialization, but you got to think about both. What not beyond the scope of this amazing write-up, but like that's like where my brain goes because I like that. So there are three realms to keep in your head. Plugin realm, JSVM runs on trusted plugin code, limited API, so that's the hell sandbox where you can't have any fun except for when they secretly let you have fun, or you let yourself have fun. Main context, the Figma editor UI, trusted, runs the real app state, React tree, feature flags, etc. So this is just like the client-side web page. It's like, we're in a real DOM, we've got a real web browser, I love running JavaScript. Then the desktop shell for the Electron client, main process side with privileged IPC handler. So this is like the backing Node.js process of the desktop app. The callbacks on the JSVM bridge, things like the one for Figma JSX deserialize, are the places where data flows from the plugin realm into the main context. That's where expression parsers, deserializers, and any just-to-helper function become extremely interesting. Keep this picture in your head: plugin, bridge callback, main context. For desktop IPC, main process, that's party zone. That's the library we're going to climb, or the ladder we're going to climb. Sorry, I'm just checking if I was recording. Guess what? I am. Bet you didn't know that. Alright, bug number 1, a counter function with a prototype pollution inside of it. In my opinion, this is like, well, there's a lot of good parts of this report, but the fact that this was able to be escalated into anything rules. While grepping through the bundle.js, I hit this tiny arrow function called EG. Its job is to count how many times each property equals value combination appears across a set of Figma variants. Variants are basically states of a component. Think state equals hover, state equals pressed. So you've got some fun code. Read it slowly. T is a plain object literal, yeah. So it inherits from object.prototype. Notice they didn't use object.create null here. Then user-controlled variant data is used as the keys E and R. So look at that. That looks kind of, what are we doing here? Potentially truthying things that are potentially interesting, whatever. If I can make E equal proto, then T proto is object.prototype, and the next line writes object.prototype R to an integer, textbook prototype pollution. So this is interesting. The UI blocks it, the plugin API doesn't. If you try to literally name a variant property proto in Figma UI, it gets blocked, fair enough, but the plugin API doesn't apply the same sanitization. Essentially, yeah, that makes sense, because when they talk over the bridge, it is after whatever logic that would have been. This is a classic bug bounty shape and worth filing away. A UI layer denialist that isn't mirrored in the programmatic API. When you see sanitization on the front end, always ask, does the backend API enforce this too? And on Figma, backend very often means the plugin bridge. Yeah, so this is also an interesting context where it's like, I mean, even the developers aren't even thinking right about this. Problem, the pollution crashes the entire app. Also, the problem is that the pollution sucks. Like, it's like limited to just setting a value as truthy, or setting it to 1 and then maybe being able to increment it further, but like, I hope you're not, like, what are you even going to do with this, man? Like, okay, so you can, even if it didn't crash, you're like very limited in the gadgets you can try to abuse. Although I'm thinking of really funny situations that aren't. Like, I really like this write-up because it's such a fun bug chain and I'm a little too excited about it, but, right, okay. If you try to literally name a variant property proto in the Figma, wait, I already read that. All right, yep, okay. Yes, so this pollution crashes the entire app. When EG runs with proto in the mix, it does this. So yeah, I've had to deal with this before, by the way. It makes me so sad. Normal assignment creates properties with enumerable true by default, and that's what tanks everything. Once object.prototype.poc is enumerable every for in loop, every object keys, and every inherit on an inherited aware path. Every framework hop path that iterates over object keys suddenly sees a POC property that shouldn't exist. Yeah, I've seen this crash. I can't even say, even though it's like a public, Figma's main context hits an unexpected key in code that was never built to tolerate one, and the editor dies on the spot. Yep, sounds about right. Good luck. So from the surface, this looks like a DOS at best. Not exciting. True. 2/3 of the insights, the plugin survives the crash. Here's the detail that turns this from noisy DOS into foothold. When the main context crashes, the JSVM keeps running. See, that's nice. The plugin is in a separate realm from its own heap, its own event loop-ish execution. The editor UI being on fire doesn't stop my plugin code from continuing to execute. This means the sequence plugin pollutes object prototype X, main context crashes, plugin keeps going. Hold on, I'm still distracted by Yeah, I don't know about this. It'll show up on like for in, so for const x of. Will it show up on these? Wait, how do you do that? What? Can you iterate keys that way? What's the right way to? Is that right? Okay, yeah. So it will pick up. It'll pick it up in for in loops, but it won't pick it up on object.keys. Sorry, I was like, wait a minute. I'm pretty sure it doesn't. And so. Nope. On an inherited aware path, yeah, that might. I'm not sure. I'm not sure what this means. But whatever. If you're not sure what's going on here, don't worry. We're just having JavaScript thoughts that are the intrusive JavaScript thoughts are winning. All right. Yes. So, yeah, JSVM survives the crash, which means it can try to do some funny stuff. Yes. So, it's in a weird state where the JSVM code execution continues, but the UI is dead, and any code that tries to have fun with stuff over the bridge can't because it won't talk anymore. Is there anything useful in the main context reading off of plain objects that is worth controlling? And it's such limited control, but this is why I like this, because it's like, dude, this isn't exploitable. Like, this is like weird behavior, definitely technically PP, but like, what are you gonna do with this? This is no. And then we get the answer, and it's like, wow, RCE is what we're gonna do with this, despite how much it sucks. Like, fundamentally, like, wow, that's why this is a great write-up in my opinion. Like, this linchpin piece of like turning such a dead end, like, bad behavior where it's like, dude, you're not gonna be able to do anything with this, into ha 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 ha, there's actually a god gadget that is just gated. Alright, picking the right feature flag to forge. Figma, like every SaaS at scale, gates internal/unreleased APIs between feature flags. In the bundle, these look like calling a function to get the object back with feature flag configuration dot some flag name. Function call that returns an object, and then a property reads off it. Reads like this go through object prototype lookup where the property is missing. Yeah, so there's like so many like feature flag lookups there where it'll like pass some function name as a string. Like, you're lucky that this works. And you're lucky that they've got this. But anyway, we'll get into this. So with prototype pollution, I can make feature flags that don't exist on real config objects appear to be true by writing them to object prototype. Yep. The only question is which flag is worth forging, so I went flag hunting. The winner was JSX debugging. When it's on, Figma attaches a JSX sub API to the VM object, which notably Figma JSX deserialize. Or most notably, here's the gated code in the bundle, and it's like, yeah, we're just gonna like set that to be truthy, and then it'll be like on, and then we can talk to this from the JSVM. Figma JSX deserialize takes a JSX string, parses it, and evaluates that JSX expression as real JavaScript-ish expressions. It's just I've never seen any implementations of this, and I think that there's like a core, like, what is it, JSX parse. This is just free. Like, it should almost always, even with a strict CSP, lead to free XSS. And so we'll kind of get into like why there's some extra unnecessary steps here when we get there. But that sound you just heard is every hacker's ears perking up. Yeah, you get boing. If I can flip JSX debugging and call that function, I'm holding a mini expression evaluator that runs in the main Figma context. Party time. That's a vastly more powerful primitive than the integer-only counter pollution I started with. Bug number 2, prototype pollution inside Figma JSX deserialize. I wouldn't even say that. This is just, yes, inside this, yes, like the fact that this can get, I would just say code execution. I wouldn't even say, like, it is code execution. Because you can just call big F function constructor, and whatever, we'll get into that. Let's trace Figma JSX deserialize from the JSVM entry point down to the part that actually executes user code. This is the core gadget, so I'm going to walk through every hap. So we have the VM call that registers the JSX callback thing to the VM over the bridge. Yeah, so they're having fun. RZ that has deserialized JSX, which is like presumably where the party's at. Doesn't matter. The point is that it gets passed into a JSX evaluator. The main name, the method name that is doing a lot of heavy lifting, here we go. Parse and stringify expressions. So the parser isn't just parsing JSX, it's actively evaluating expressions. Yeah, so that's GG at that point, like that's code execution. There's steps here that, we'll get into it. But like I've popped bugs here before and I love it so much. Expression evaluation begins, so you've got fun going on. Essentially all of the inside JSX get fed back into parse expression. Now let's look at the 3 AST node types that make this whole thing work. Identifier resolution is the money shot, so you can get references to big F function. I'm just gonna, I might even skip all the, we're running this straight. So notably, we'll get, all right, if the identifier isn't bound to the current scope, it's resolved against a fresh object literal. This glance, it looks like a safe fresh object, has no properties. It does not matter. None of this matters. So the identifier constructor resolves to object constructor. That's but like, of course it's gonna. That's the single most important observation in this bug. No. The sandbox designers assumed unbound identifiers would return undefined, but happily walks the prototype chain. That's expected behavior. The sandbox designers, I don't know why they weren't thinking about, I don't think that JSX was supposed to be exposed to this. How did they even do? I don't know. Member expression resolution. So the problem here is that the Figma app lets you have JSX get evaluated over the bridge. That's the problem. Like, you cannot have JSX evaluation. You're not going to be doing it safely. Sorry. Go do it in a sandbox. Right. So anyway, so member expression resolution. You can get nested properties. Woo. It does bind things to a receiver, but we're just getting big F function constructor and calling it. That's what I'm doing. Right, okay, so essentially, he uses it to call object defined property and pollute the global prototype with some fun stuff, which is great, and you can do that. And I've had to do that I've deliberately done that just to shorten payloads where I leak a window reference, and then in the JSX expression, so you can leak it from some elements. So they'll have a dot owner, and you can follow the chain up quite often. But fortunately, his CSP in the target app allows for unsafe eval.js, as we'll see later, which means it's already over. It's already just RCE here, or not RCE, XSS, because it's a client-side context. But so you can grab a reference in your JSX expression in the AST evaluator to object, and then call define properties, and then you can call those on object prototype, and now everything has those properties, which is nice. And sometimes you need that if you don't have unsafe eval and you want to do something more complex, like create an iframe, and then create an iframe to a page that has a weaker CSP that you can then call .eval on and get full code execution. A quick but important caveat: this parser is not eval. It doesn't have a global scope. It doesn't give you access to window. You might be able to chase one down with if you put another JSX element inside of this expression. I've been able to get window expressions that way. You can only pass arguments. The parser knows how to evaluate, so arbitrary JS is an overstatement. You can actually have arbitrary JS, as we'll see later. What you actually get is any function reachable from, which turns out to include object. You can get so much stuff. You can get big F function constructor, and crucially, big F function constructor. You could just get it and call it. It's just code execution. Just do that, as we'll see. And now, if there wasn't unsafe eval, we couldn't use this, which is sad, but the huge upgrade over bug 1 is that I can now set enumerable false. True. Alright. True. But we don't need to pollute anyway. This alone fixes the main context crashes problem for any pollution I do through the path, which is exactly what I'll need to keep the app alive when I exploit it. Yep. Alright. And then this is very interesting. Getting the race condition worked out, which rules. Race condition forging a feature flag long enough to use it. Okay, time to slow down, because the timing here is the cleverest part of the chain and easy to gloss over. Yeah, this is definitely insane. Here's the situation I'm actually in. I need the feature flag check to hit a polluted object prototype so that JSX debugging reads back true, and that the Figma JSX is attached to the VM bridge. Pollution needs to, it's going to crash the main context. So the flag check only runs during the plugin initialization. So if the plugin is already running when I pollute, flipping the flag does nothing. So he needs to restart the plugin after the pollution lands, and there's a way to send a message that restarts the plugin that's handled by the main context. But if the main context is already crashed, then the restart can't happen. So yeah, that's a condition I would prefer to not be in. I'd prefer for it to just not crash, right? That'd be a better deal. I need the main context to be alive enough to process a post message handler and reinit the plugin, but polluted enough at the moment of the feature flag read that JSX debugging comes back true. The good news is that crash isn't instantaneous. The main context tears down over many frames because the enumerable property only causes errors when someone actually iterates a plain object. So there's a narrow window where the post message pump is still turning and object prototype JSX debugging is already set. If I fire the restart inside that window, the new plugin instance will see JS debugging equals true. How many? 1, 2, 3, triple. Alright, my bad. I should have said a third equals. During its init path and gets Figma JSX deserialized attached. Brute forcing timing is ugly but effective. After a lot of trials and errors, I got the success rate up to 99%. Nice. One funny, very bug bounty detail. The race only wins when the plugin is published, not when it's run locally. Yeah, that sounds about right. Published plugins go through a slightly different load path with slightly different performance characteristics. Hey, it'd be so annoying if it was the other way around, where it's like, I can get it to work locally, but not through the published one. And that difference is just enough to tip the timing in my favor. If you're ever chasing a timing bug on Figma and failing, try publishing privately before giving up. The exact brute forcing loop lives in the attached plugin code. It's long and not that interesting conceptually. The takeaway is restarting repeatedly and hoping the timing lines up with the window opened by bug one's pollution. That's good. There's no because sometimes you might be able to cause other code to block and do some stuff if you pass it. I've had bad experiences trying to synchronize. Okay. Cleaning up the crime scene with Figma JSX deserialize. So this is where I'm going to get here. You want to see how we win this? Once the race is won and I've got the Figma JSX deserialize exposed to the plugin, my first move is to uncrash the main context. The reason the main context was crashing was that JSX debugging and friends existed on a prototype object with enumerable true. Figma JSX deserialize lets me call a defined property with enumerable false, which keeps the flag low. Okay, that's a good trick. But also, if you're even this far, who cares if the main process is crashed? If it's willing to interpret this, you can just get your execution in that context. So here's, alright, we'll get there. From the moment this runs, for in loop stop trick, bring over JSX debugging, and the main context recovers, the editor is alive again. Oh, okay, so it brings it back to life. How? Whatever. If it's already dead and won't talk to you. The app looks normal, but is still true. So anything else? Yes. Now I have a stable, non-crashing Figma with an expression evaluator inside the trusted main context and full control of the prototype chain. Time to turn that into actual JavaScript execution. Here's how we're going to turn this into actual JavaScript execution. So we'll actually read through this and then I'll get extreme. It's not even extreme. From prototype pollution, the error handler gadget. Prototype pollution gives me values on arbitrary property reads. To get code execution, I need a gadget, a place where the main context reads a function typed value off a plain object and then calls it. Destructuring with defaults is the classic shit. For this in Figma has a beautiful example in the plugin VM setup. Yup. There we go, grabbing some error handler from a destructuring. The destructuring pulls error handler off E using regular property access. If E doesn't have its own error handler, JavaScript walks the prototype chain and happily returns object prototype error handler, which I control. How are you going to create an arbitrary function? Then later, it gets called. Y is the destructured handler, and it's stored as is. Yes, there we go. So set error handler E, this error handler equals E, so it gets invoked whenever a plugin throws. So the gadget is pollute object prototype error handler with a function, then throw something in the plugin. The function is called in the main Figma context. That's arbitrary JS execution in the trust boundary I care about. But wait, the JSX evaluator can't write function. So true. Here's the fun problem. Figma JSX deserializes tiny AST subset doesn't include function literals. I can't type function 1 inside a JSX expression, so how do I get a real function object onto object prototype? Well, you have function call for sure. The answer is the same pattern we used to reach object. Walk the prototype chain until you land on something useful. So you've got the object constructor and then constructor function, the constructor that turns the string into real callable function objects. That's our loophole. Yeah, so basically instead of doing this, here's what we do. This is like unnecessary. So here's what we do. We're not even calling define property. We will just do, check this out. Whoops. We don't want to name it. So essentially what this does is this gets a reference to big F function constructor like we're doing here, calls it with a string for the function we want defined, and then we can just call the function. Whoa! So because the JSX evaluation is happening in the this side, right? Yes, it's on this, wait, trust boundary I care about, yeah. So this is happening in the main Figma context because you're not passing a serialized function over the bridge. If you can pass serialized functions over the bridge, that's already GG. Don't tell me you can do that. So this is, we know that the JSX resolution is in the, or JSX deserialization is running in the main DOM, so we can just do this, right? Yes, this is in the main DOM. It has to be, because otherwise there's no way you're passing functions over the bridge and from one context to the other. So yeah, we just do that and don't need to rely on this behavior. Yeah, because it's like polluting to the DOM. So yes, we are in the context we want to be. You can just do this. This is cool, but given that this is possible, that means we have unsafe eval. So we can do that instead and skip all of the needing to worry about the error handler and pollution stuff. If we don't have unsafe eval, that's when we need to get trickier and we want to get some sort of like DOM write or window reference access in the AST evaluator and be able to create a frame that is on origin and for whatever reason doesn't have the CSP applied. It really depends on the target. Whatever. All right, we're not following. Whatever. Yes. So look at that. He gets XSS. That's the moral of the story. And boom, there pops the alert. It doesn't matter how extra it is, but that's just XSS. Not really RCE. It would be really cool to chain it to RCE. That would rule so much, but we'll see if we get that or not. Yeah, this I like this a lot. Okay. On Figma Desktop, Electron, an XSS in the render is only half the journey. Electron Sandbox and the context isolation should protect the node side, but if any IPC handler exposed to the render does something dangerous with its arguments, that's your bridge. I pulled the desktop apps app ASAR, cracked it open, and gripped the IPC handlers. This one stopped me cold, so here we go. It's the write file path handler, and it receives some arguments. So that's probably some reference to something. There's some data it gets. So it looks for t.path, and we'll just write a binary file to an arbitrary path. Yeah, that rules. Thanks. Nice gadget. Read that handler carefully. It takes a caller supplied path, happily ensures the parent directory. And unless the caller asked for deny overwriting files true, why would an attacker writes raw bytes to disk with no path validation, no allow list, no user prompt? Translation: any render side JS that can call this IPC can write arbitrary bytes to any path the Figma process has permission to touch. On Windows, that includes the user startup folder, persistence, app data, drop a malicious DLL for some app's next launch, or the user's own binaries on Mac OS Linux. Same idea with different paths. Cross-platform RCE is just a matter of where you write the file. Yeah, do you have a way to leak user directory or like user? Let's say you're writing this on Windows, and let's say Figma's installed to app data, and Figma can like overwrite itself. Let's just do that, right? I don't know. Or write the user startup. You still is it relative? I don't know. Whatever. We'll see if we see a full POC that like explains what that looks like. Reaching the IPC from render.js. The IPC isn't exposed on window directly. It lives inside a Webpack module. To reach it from my XSS context, I have used Webpack's own chunk loading mechanism to get a hold of its internal require. So it's grabbing from here. Let's see. Okay, so that's nice that it's able to, yeah. The Webpack trick here is worth remembering on its own. If the render is a Webpack bundle window.webpack chunk underscore name.push with a callback third argument leaks the internal require function, that's so much better than like having to just pollute something or like overwrite some global function and then get code to be called. Then that's so annoying always. So that's nice. From there you can load the module and the bundle by ID and reach things the app never meant to expose on globals. Here we go. The final single payload chain, everything collapsed into one JSX string that when passed Figma JSX deserialized, pollutes object prototype. Error handler, the function that runs the Webpack IPC, write file path payload. So yeah, you can do it that way. Zoomed out the full chain of the plugin drives. Zoomed out, the full chain of the plugin drives looks like this. One seed, create variants with proto equals POC, property name via Figma create component, combine S. Select them to trigger e.g. bug number 1, prototype pollution, main context starts crashing, erase, brute force the restart call over the bridge using narrow, alive enough to post message but already polluted window that plugin reinits and has the JSX debugging true so that the deserialized JSX functionality gets attached. Stabilize used Figma JSX deserialize to redefine JSX debugging with enumerable false. Main context recovers. Editor is healthy again. I'm not sure if this is necessary. If you're already able to run that defined property in the main context, why not just call the big F function constructor and get script execution? Like, who cares that the app's crashed at that point if you have script execution in the DOM, and then you can like grab a reference and talk to the big boy bridge, and then just get your code execution. Plant the gadget, use Figma JSX deserialize to set the error handler that then gets called instead of just calling it yourself or getting it to call it itself. Reinit so that the plugin rereads error handler. Detonate, get it throw an error from inside the plugin. The error handler will run again. That's but the interesting piece then, and I feel like it should be pulled out into its own step. We have XSS in the like web context. Now we got to escape over the IPC bridge. I'm surprised that the get like an actual crafted file array wasn't defined here. I'm glad they didn't push back too much on that because that's always sad. From the victim's perspective, they ran a published Figma plugin. That's it. No consent dialogues, no suspicious prompts, no second click. 0 click from running a plugin, cross-platform RCE. Thank you. Thank you for reading this, and thank you so much to all the critical thinking team that is always providing very cool content. So yes, alright, yes, this write-up rules, and this chain rules, and the fact that it was all able to come together is awesome. Let's play the game of research review format. So how this generally applies to BB, yeah, this like level of depth on this target is really nice, and just like really taking everything apart and understanding how it works and being able to think about like, man, what do I wish the application would do? And really, like, this just shows a really good understanding of the threat model and just the ability to push through and escalate on, like, some of these gadgets that seem kind of limited or seem like one thing, and just pushing it all the way to full chain rules so much. Why did this work? Because JavaScript was a mistake. But why did this work? Because JavaScript was a mistake. Further research that should be done here. Well, number one, these contexts are insane. I guess like it doesn't really matter probably if this payload could have been simplified notably, but I'm pretty sure you could get a window reference in there, and if not, based on everything, you should just be able to call the result of calling big F function constructor and skip some steps that way. Not really relevant for future research here though, but what is interesting to me is how the hell does the deserialization over the bridge work, because it looks like there's some pretty complex types that are supported when sending stuff out of the JSVM context into the main context. So how is that implemented, and can you send really funny stuff from the JSVM context that just on deserialization leads to code execution in the main context. Especially given that you have unsafe eval, I'm pretty sure that would be fun attack surface to explore, and it has to do with like how the JSVM library implements its stuff, and so you're kind of looking for a bug in the library, which seems like Figma's pretty cool, and then if you could weaponize it, they might pay for it. I don't know. Right, rating. What do I rate this? I rate this JSX attribute expansion. I rate this parentheses a tag dot underscore owner dot follow up all the way to a window chain out of 10 because that's cool. But yeah. Yes, so shout out davensec. This is crazy research. He seems to be killing it on the Figma program. I'm hoping more stuff will be able to be discussed, because like bugs like this rule. I love the full chain everything. I love the JavaScript hell, and descending to JavaScript heaven. Like we went from like the saddest, most limited prototype pollution that crashes the application to okay, so it had the user hard coded. That all right, sorry. Sometimes you want like you can't, all right, whatever. I'm not pushing back on this. I'm not the program. Yay, hacking. Good write-up. I liked it. Definitely showcases a lot and a lot to think about from here. So thanks for watching.